Find the sum to n terms of the following series. Let us begin. So here we have a series given by 3 plus 7 plus 14 plus 24 plus 37 and the rest of the terms. Now clearly this is not an arithmetic series because it does not have any common difference. However, if we take the second term 7 and from it subtract the first term, that is 3, that's going to give us 4. Next we take the third term and from here subtract the second term, that's going to give us 7. Then we take the fourth term and subtract the third term from it, that's going to give us 10. Then we have the fifth term and from here subtract the fourth term, that's going to give us 13. Now clearly we observe here that 4, 7, 10, 13, these are the terms that are going to be in arithmetic progression. Fine. Which means that now what we'll do, we'll use this method. This method is known as the method of difference. So here let us begin by supposing that Sn represents the sum to n terms of the original series and its last term is given by Tn. Tn is representing the last term, then Tn minus 1 is going to be its second last term. Now we'll be considering the same sum Sn. So we have 3 plus 7 plus 14 plus 24 going all the way up to Tn minus 1 added to Tn. Now we're going to perform a subtraction here. Now on the left hand side we have Sn minus Sn, that's equals to 0. This is going to be equals to, we'll keep the first term of the first series, that is 3, intact. Let's keep it as 3. Now what we do, we take 7 and from here subtract 3, so that's going to give us 4. 14 minus 7, that's going to be 7. Then 24 minus 14, that's 10 added to 37 minus 24, so that's going to be 13. Then we have the rest of the terms going all the way up to Tn minus 1. So we've considered Tn from the first series and Tn minus 1 from the second series, and we have the remaining term of the second series, that will be negative Tn. We'll transpose this negative Tn to the left hand side and that's going to give us Tn. This is going to be equals to 3 added to, we have 4 plus 7 plus 10 plus 13 going all the way up to Tn minus 1. Now Tn minus Tn minus, this is a single term. Now immediately we can observe that this is an arithmetic series. Now for this arithmetic series, the first term equals to 4, the common difference d, that's equals to 3, and it has got n minus 1 number of terms. Now why does it have n minus 1 number of terms and not n number of terms? That's because if we consider the first series as n, here we have excluded the first term 3 and we consider the second term all the way up to the last term. By definition, Sn has got n number of terms. If we exclude any one of the term, it's going to be left with only n minus 1 number of terms. This goes the same for the second series. We consider the first term all the way up to the second last term and excluded the last term, that is Tn. So this one also has got n minus 1 number of terms. Now subtracting one n minus 1 terms from the other n minus 1 terms leaves us with n minus 1 number of terms. We know there's a standard formula for obtaining the sum to n terms of any arithmetic series, that's given by n over 2, where n gives us the total number of terms in that series, multiplied to 2 times the first term added to n minus 1 times the common difference t. So let's use this formula. This is going to help us obtain the value of Tn. We have Tn equals to 3 added to the sum of the n terms of the arithmetic series, that's given by n minus 1 over 2. Multiplied to 2 times the first term added to n minus 1 times the common difference, which is 3. So when we simplify this, that I'm leaving as an exercise, it's a very simple algebra. So this is going to leave us with 1/2 multiplied to 3n squared minus n added to 4. So this is going to be the nth term of the series. Now that we have the nth term, we can use this to obtain the sum up to the n terms. Now sum up to the n terms, that's defined as take the summation of tk, or the nth term. All we have done is replace the index n with k, and k here is to go from 1 to n. So that is going to be equals to summation of tk is the same as summation of half times 3k squared minus k added to 4, and then we have k running from 1 to n. So let's try to find out this particular sum. So here we will have half 3 over 2. So let's take 3 over 2 multiplied to summation k squared where k goes from 1 to n, minus 1/2 times summation of k with k running from 1 to n, added to 4/2 multiplied to summation of 1 with k running from 1 to n. Now we have a standard value for each of the three summations. So the first summation will be, this is the sum of the squares of first n natural numbers, the formula being n multiplied to n plus 1 times 2n plus 1 whole divided by 6 minus 1/2 times summation of k. So that's going to be the sum of the first n natural numbers, which is given by n times n plus 1 divided by 2 added to, so 4/2, that's simply 2. Now summation of 1 means we have 1 added to itself n number of terms. So this is going to be 1 multiplied to n. Now when we simplify this is going to give us finally n/2 multiplied to n squared plus n plus 4. So this is going to be the sum up to n terms of the given series 3 plus 7 plus 14 plus 24 plus 37 all the way up to n number of terms.